to our third video on electricity. In this lesson, we're going to look at schematic diagrams, how to read those diagrams, and about the two different kinds of circuits, series and parallel. We'll also look at how to calculate equivalent resistance for both series and parallel circuits. We'll continue our investigation of Ohm's Law by looking at how those relate to these circuits and their different configurations. Let's take a look at series and parallel circuits. In a series circuit, there's only one path for the electricity. So this is a schematic diagram, and we're going to represent a battery with these two lines. A regular line indicates a wire. And we're going to create a schematic diagram of a series circuit. I'm going to put 3 light bulbs in a row here. Okay. Electricity only has one path to travel through these bulbs. If I were to remove one bulb or one were to burn out, then that circuit would be broken and all of the lights would turn off. This is a series circuit. In a parallel circuit, we have multiple paths for our electricity. So when we connect our 3 light bulbs in parallel, like this, if one bulb were to burn out, then the electricity could travel through this juncture and through this one, and both of these lights would continue to glow. This is a parallel circuit. We saw that a battery in a schematic diagram could be indicated by 2 lines. But there are some others that you might encounter. There's something called a resistor, and it's indicated by this zigzag line. A straight line indicates a wire. And light bulbs are shown in several ways. Sometimes you'll see them like this. And a light bulb actually is a form of a resistor. Let's assume that we have a series circuit in which we have 3 resistors, each with values of 3 ohms, 2 ohms, and 5 ohms. What is the equivalent resistance of these when they're hooked together in this series circuit? When we're looking at resistors in series, all we have to do is add them up to get the equivalent resistance. Now let's look at those same resistors, but this time they're connected in parallel. To find the equivalent resistance for resistors connected in parallel, we use the inverse sum of all those resistors. So we do 1 over the equivalent resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3, etc. When you put these in the calculator, you don't need to worry about putting them in as fractions. You can do parentheses 1 divided by 3, close parentheses, plus 1 divided by 2, close parentheses, and so on. When you get your answer, in this case 1.033, remember that that is not the equivalent resistance. We still need to find the inverse in order to find our equivalent resistance. So we do 1 over the number that we've gotten, and that gives us an answer in this case of 1 ohm. Now let's use our knowledge of equivalent resistance and Ohm's law to find the current in a series circuit. We're going to use our same resistors, and we're going to provide a voltage of 12 volts. Now notice that Ohm's law tells us that the current is equal to the voltage divided by the resistance. We want to find the current here, so we're going to take the voltage and divide it by the resistance, the equivalent resistance, to find 1.2 amps is the current in our circuit. Now let's take that same potential difference, that same voltage or battery source there, and our same resistors. This time we're going to look at our equivalent resistance in parallel. Remember that we must use the reciprocal of each of those in order to find our equivalent resistance. And we found that that was 1 ohm. Now we're going to divide the voltage by our equivalent resistance of 1 to get an answer of 12 amps. You're now ready to take your quiz in Google using the link found in the teacher notes. Please look over the note sheets to assist you before you engage in this short quiz. Once you complete the quiz, look over those notes again and the ones from previous lessons to assist you in taking the Unit 2 electricity test.